RunPod just came out with a pretty cool new service tool called RunPod Flash. It is designed to simplify how we deploy serverless GPU functions. Traditionally, moving a local Python script to a cloud GPU required building a Docker image, setting up the environment, pushing it to the registry, and managing a separate deployment. But Flash removes that burden by letting you turn standard Python functions into cloud endpoints using simple decorators that you can execute on demand. In today's video, we'll take a closer look at RunPod Flash, see how it works, and try it out for ourselves by building an on-demand AI video generator. It's gonna be a lot of fun, so let's dive into it. RunPod Flash essentially works by abstracting the infrastructure layer entirely. Instead of you managing the deployment, the Flash SDK packages your code and your dependencies and then pushes them to a managed worker which only exists while your function is running. One of the best features is the automatic environment sync. I'm coding this on a Mac, but Flash manages all the cross-platform heavy lifting, ensuring that every library is correctly compiled for the Linux GPU workers the moment I hit run. It then silently provisions a serverless endpoint for each function, meaning you get independent scaling and hardware for every dedicated task without ever touching a configuration file. But the real magic happens when you integrate these functions into a backend service. Because each decorated function is essentially a live API endpoint, you can trigger them from a web app or from a Discord bot or from a mobile backend with zero extra setup. And the architecture is perfect for scaling because you can fire off dozens of parallel jobs at once. For example, if you have 10 users waiting to generate AI videos, Flash simply spins up 10 independent workers and then shuts everything down the second they are done. So you aren't stuck waiting for a single GPU to finish the entire queue. The infrastructure simply grows or shrinks depending on your traffic. Now you might think that such a multi-stage pipeline like this, mixing different hardware and data, would require a complex orchestration layer. But in Flash, it's literally just passing a variable from one function to another. To show you how powerful it is, we're going to be building a multi-stage pipeline. First, we'll use a simple cheap CPU worker to handle pre-processing. In this case, we'll be adaptively resizing input images, and we will then pass that data, meaning the resized image, to a high-end RTX 5090 GPU to generate a high-fidelity video using the Cog Video X model. So this ensures that we're not wasting money on top-tier GPU for simple tasks like image resizing, and we only call it for the functions where we need the heavy lifting. So to get started, we can create a virtual environment using UV, and then add RunPod Flash, and then reload the virtual environment to make sure it's working, to make sure the environment path variables are reloaded. And then you have to log into your RunPod account by running Flash login. And from there, we can move on to setting up our actual endpoints. So here I have a simple Python file, and as you can see, it's pretty small, and it has two Flash endpoints. One is doing the adaptive resizing for input images, as I mentioned earlier. And as you can see here, it's just using a simple CPU and calling an image resizer. Nothing fancy, and we don't need anything fancy for such a simple image processing operation. But on the second endpoint, we have our custom video generator pipeline where we are spinning up a dedicated GPU instance with an RTX 5090 and using the 5 billion parameter Cog Video X video generator to create a video based on our resized input image. And now we can see how it works when we run it. So we can just add a simple image of this dog and then provide a prompt that we will be using for the video generation. And if we go back to RunPod now, we can see that there are two dedicated workers with an active queue that are processing our image and our video. And I have to mention that when we run these endpoints for the first time, you might encounter that the pipeline takes considerably longer. That's because RunPod is essentially installing all the dependencies and downloading the model weights, but every consecutive run after that will be considerably faster. So now let's wait a few more seconds until the pipeline finishes. And there you go. We now get our nice little output video. And on the RunPod Analytics tab, we can also track how many deployments we've had, how many have been successful and how many have failed. And also we can keep track of our billing. So there you have it. That is RunPod Flash in a nutshell. I honestly think this is a super cool feature if you're building any backend service that requires a heavy on-demand AI processing task like image generation, video generation, or heavy document analysis, or anything of that sort. But what do you think about RunPod Flash? Do you think this feature is useful? Have you tried it? Would you use it? Let us know in the comments down below. And folks, if you like these types of technical breakdowns, please let me know by smashing that like button underneath the video. And also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.